Welcome to this lecture. So, before proceeding with the derivations of certain theorems related to probability, it will be wise enough to let's start revising the earlier first with the axioms of the probability. So, considering this case, so we typically we deal with these variables. Apologies. Okay. So let's say we are conducting some random experiment and it has some certain outcomes. So your samples, it will have certain definition called sample space, which is nothing but all possible outcomes of a random experiment. And out of those sample spaces, it is wise enough that you can have certain number of events of interest to which we are going to assign a probability. So we denote this probability of certain event as P of A, as you can see in the screen. So beginning enough, so we have certain axioms in probability that needs to satisfy that when can we say that yes, P of A is a probability to a certain event. So following it, axiom 1, you can see that probability of any event is a positive, non-negative, like greater than equals to 0. Probability P of S, sorry, it is very wrong to say that. Okay, P of A is greater than equals to 0 is axiom 1. So for second axiom, we say that P of S is 1, and third axiom is saying that assuming that you have a mutually exclusive events or a disjoint set, where we say that let's say capital S is my sample space, and within that we have A1, A2, A3 as my events. So when we say these three are disjoint sets, it means that A1 intersection with A2 is null, A1 intersection with A3 is null, and similarly A2 intersection with A3 is null. This we are defining it for this example. So similarly, if you want to generalize it for any uncountable number of sets where which deals with the where this axiom 3 comes into picture. Axiom 3 says that if you have an uncountable sequence of mutually exclusive events A1, A2, dot dot dot, so we can assign probability with probability of union I equals to 1 to infinity A of 1 can be written as a summation of I is equal to 1 to infinity P of AI. So with this sort of recap, we will proceed forward with certain derivations involved. So coming with our first theorem, we'll see so theorem 1. The probability of the empty set phi is 0. The probability of the empty set is 0. That is, P of phi is 0. So let's see its proof. We will be attempting this proof with the help of axiom 3 that says that probability of union of AI where I is ranging from 1 to infinity can be written as summation of P of AI again from 1 to infinity. Assume that my first event AI is the entire sample space S and the rest A2, A3, dot dot dot, they are all null set. So with this, if we substitute in this above axiom, let's say I'm writing this 1, so we can write it as union I is equals to 1 to infinity A of I is nothing but A of I union A of 2 union A of 3 dot dot dot. So you have S union phi which is ultimately S. So from 1 we can write P of S is equals to, which is equal as this, can be written as summation of I is equals to 1 to infinity P of A, which I can write like this: P of A1 plus summation of P of AI, where I ranging from 2 to infinity. So as in our case we have mentioned that A1 is my sample space and AI for all I greater than equals to 2 is my null set. So substituting here we get, P of S plus summation of I is equals to 2 to infinity P of phi. On the right hand side we have already PS, so in total we can write P of S is equals to this right hand term, P of S summation of P of phi ranging from 2 to infinity. This will get cancelled. This is obviously both are 1. It will get cancelled. So ultimately we will arrive at this expression is summation of I is equals to 2 to infinity P of phi is 0, which alternately we describe that P of phi is 0 for all I 2 to infinity. Hence we have proved that probability of null space is 0. Axiom 3. Here is a note. In standard textbook you will find that axiom 3 is stated for countably infinite collection of mutually exclusive events. Axiom 3 is stated for countably infinite collection of mutually exclusive events. Mutually exclusive events. It is P of union AI, I is equals to 1 to infinity. It is summation of P of AI, countable addition. We say this is countable addition. Often say we say it as countable addition.